Okay, so this is example 3, and it kind of I'm going to do it two ways. I'm going to do it with the p-value and alpha. That's one way to do hypothesis testing. Then I'm also going to do the version where you're comparing the critical value to the z-score, the test statistic. So first version is if we're doing p-value. So the first thing that they tell us is the claim is the mu is 40. Alpha is 0.05. We are given the test statistics of X bar mean of 39.2, standard deviation of 3.23, and N is 75. Since N is 75, we know we're using the z-score, and we are going to do the thing. So step 1 is we're going to write our null and alternate hypothesis. So since the claim says mu is equal to 40, that is going to be our null hypothesis because that always has to have the equal sign. And I'm going to write claim next to it. And that alternate hypothesis would be that it's not equal to 40. And because it's a null alternate hypothesis is not equal to, our step 2 is to immediately draw our bell-shaped curve. And we're going to show that it is two-tailed because it is not equal to on the alternate hypothesis. Okay, that's really the only thing the alternate hypothesis does, is tells us what to do with our shading. Now, because that, and then remember the shading is totally, all of it is alpha. So since we're two-tailed, we have to go alpha divided by 2 to figure out what each side of that is going to be. So 0.05 divided by 2, and making sure I don't make any mistakes with math. 0.05 divided by 2 is 0.025. So the area inside the shaded area is 0.025. Okay, so on either side. Now, when we do the test statistic versus the critical values, that number is going to be important. But when we're doing it in terms of the actually, it's going to, both of them are going to be, it's going to be important either way, because the p-value will be based, we're going to be looking at, is it inside this area or inside this area? And so we have to use the alpha over 2 because it's two-tailed. Okay, so step 3 is we have to find out what is the p-value. So we're going to find our z-score, which is x bar minus mean over standard deviation divided by the square root of n. So that's the formula. And that's going to be 39.2 minus our mean, which was in the claim, divided by 3.23 divided by the square root of 75. And that's going to tell us what we're going to be looking up on our chart. So 39.2 minus 40 over 3.23 divided by the square root of 75. And that gives us negative 2.14. And then we always round to 2 decimals when we're doing a z-score. So now we pull out our handy dandy chart. And 2.14 is going to be, negative 2.14 is going to be our checking spot. So negative 2.1, and then we go over to 4 and we get 0.0162. So the probability of Z is, okay, so Z is less than negative 2.14, because it's all, when you look it up in the compute on the chart, remember it's always left-tailed, so it has to fake to the left. Negative 2.14 is 0.0162. Okay, now we're going, so that is your p-value. Okay, so now we're going to compare that to our alpha. So p-value is 0.162, and our alpha is alpha divided by 2 is 0.025. Because remember, we're doing the left side. So the left side of this, because we were on the negative. The left side is 0.025. So now we compare them. Is this less than or greater than that? So in this case, it's less than. And since it's less than, the rule is when P is less than or equal to alpha, we reject. When P is greater than alpha, we fail to reject. So that's the rule. So in this case, because it was less than alpha, because 0.016 or 0.02 is less than 0.025, we are going to have our conclusion that since p-value 0.0162 is less than 0.025, which is the alpha divided by 2, reject the null hypothesis, and which means we do not have enough evidence to support the claim. And you would keep going and tell what the claim was, but they just didn't tell us the claim of mu is equal to 40. So in your final setup, you want to make sure that you have explained in your conclusion what you compared and whether reject or fail to reject the HO, and then which means that you have or do not have enough evidence to support the claim. In this case, the claim was mu of 40. Okay, so those are the 4 steps. Excuse me, 6 steps. I forgot what number it was on. Those are the 6 steps. So state your null hypothesis and alternate hypothesis, draw your bell-shaped curve, and figure out what the alpha is and if it has to be divided by 2. Find your test statistic. That's Z is negative 2.14, and that means that Z is less than negative 2.14, which is what your p-value will give you. And that's looking it up through the table. Then you compare your p-value to your alpha, in this case alpha over 2 because it was two-tailed. Based on that, you decide, look at your rule, and then have your conclusion. Okay, so that's if you have a p-value and an alpha. So the same problem, going off the same information, our claim is mu is 40, alpha is the same, x bar hasn't changed. So some of this work is going to be repeated on this. You're going to still do find the Z based on your test statistic, and you're still going to do alpha divided by 2. But what's different is we're actually going to, instead of just using the alpha and comparing it to the p-value, we're going to look up the alpha in the chart. So we're going to do a double lookup in our chart. Okay, so again, first step, state our HO and HA, which we already know our HO was the claim in this case, and the HA is not. We draw our bell-shaped curve, do our coloring, and again, two-tailed because not equal to. We know that the alpha area is 0.025 on both sides. Now, step 3 is we're going to find the critical value. Z at 0.025. That's where this changes. Instead of using the alpha and then we're actually going to be looking up 1 time instead of 2. So we're going to go inside our graph looking for 0.025, which is right here. And that z-score is at negative 1.96. So that's right here. And its positive is 1.96 over here. So that's called the critical value. Okay, so step 4 is we find the z using the formula and our test statistic. So that part has not changed. We still have to do that step. And we get negative 2.14. And here we don't have to look this one up. Okay, you don't look this one up. You only look up the critical value in the chart. So now we are going to compare, and this is why I draw a picture, because it allows me to point. Where is negative 2.14? Well, it is smaller than negative 1.6. It would be right about there. That pencil broke. So we're going to compare the z value that we just found, or the test statistic, which is negative 2.14, and the critical value, which is negative 1.96. And basically we're looking to see, is it less than, or in this case, on this side, it would have to be greater than. So in this case, negative 2.14 is less than. So because of that, if this is less than that, then we reject. If the TS is less than the CV, that's the easiest way to remember it. Or the other direction, greater than. So since test statistic negative 2.14 is less than negative 1.96, which is the critical value, reject the null hypothesis, etc. And the rest of the conversation would be the same. So it just depends on which way makes the most sense to you. If looking up the alpha is easier, especially on things like where it's exactly, you look up the alpha and it's an exact z-score, then doing the comparison this way is going to be faster. If you look up the alpha and the alpha is kind of between two numbers, like if you do 0.08, if we looked at 0.08, 0.08 is going to be between these two. And either you can use your TI-Nspire to look up the exact z-score, or you could use you could just use the alpha versus the p-value versus the alpha. So there are different times when each one of these would be very useful. Okay, so that's showing both ways of doing the assignments. And what's really nice is it doesn't matter if you're doing finding the mean, like we're doing on these problems, or you have to do a t-score type problem. It would just change to a t instead of a z, or you're doing chi-squared. The steps are the same. You have the same six steps. Write your hypothesis, a null hypothesis, and alternate. Make sure you label your claim. Draw your bell-shaped curve. Label it with the coloring based on your alpha, alternate hypothesis, and then label your alpha with the amount of that the shading is. And remember that if you end up in the white, that is the do not reject area. Okay, and then either choose to look up the alpha to find out your, I'm sorry, you do either choose to look up the alpha to find the critical value, or not do that and just find your test statistic and then look it up to find its p-value, and then compare either the test statistic to the critical value or the p-value to the alpha. So it really doesn't matter which process you use, but whichever one you do choose, make sure you go all the way out and do your final conclusion. Okay? And